For part of question 1, the model class is the class with the highest frequency. The highest frequency is 18, corresponds to a group 25 to 30. So this is the model class. For part B, I'll need to work the total length in minutes. Now the total can also be thought as sigma fx. That's the numerator of the mean formula. Sigma stands for the sum. Now fx is the product of the frequencies, which is this column here, times the length. But because the length is given as a range, we'll need to find one number to represent this range of values, and the best estimate is to use the midpoint. So I'm going to need 2 extra columns, midpoint, and the product of f and the midpoint. The midpoint for the first category is 2.5. You can find this by adding the lower, the upper, and then dividing by 2. So 0 plus 5 over 2 is 2.5. For the second one, 5 plus 10 over 2 is 7.5. And you can repeat this procedure for the other 4 categories. As I said before, for the fx column, I'm just going to multiply the frequency, which is this column here, by the midpoint, which is this one, row by row. So for the first one, to find this number here, 8 times 2.5 will give me 20. For the second one, 2 times 7.5 will give me 15. And the other 4 numbers are 75, 70, 270, and finally 495. So to find the total, I'm just going to add those 6 numbers. So 20 plus 15 plus 75 plus 70 plus 270 plus 495. And the answer comes out to be 945 minutes. For question 2, I have 2 triangles, the blue and the red. Let's separate those 2 and draw them below. I'll start by using the blue one and find the height BC. I'll do that using Pythagoras theorem. So 10 squared is equal to BC squared plus 8 squared. Let's rearrange. BC squared is equal to 10 squared minus 8 squared. Put that on the calculator and you'll get an answer of 36. So BC is the positive square of 36, which is equal to 6. Now I will proceed and find EC or CE. Now this is equal to the number I found here, 6 plus an extra 5. So let's write this down. CE is equal to 6 plus 5, which is equal to 11. So this is 11. Pythagoras theorem again. DE squared is equal to 14 squared plus 11 squared. Put that on the calculator, you get 317. So DE is the positive square root, that's 17.8, and that is the final answer for W. For part A of question 3, I'll start by drawing the line y is equal to x. Now that's the line that passes through 0, 0, 1, 1, 2, 2, and so on. Now I'm going to start reflecting each vertex of this point on the line y is equal to x. So for example, if I take this vertex here, this is one diagonal from that line. So to reflect it, I'm going to go one diagonal further on the other side. So this is the point after the reflection. Repeat with other points. For example, this point here is a diagonal from the line. Go another half and you'll get the image. And then repeat this for all the vertices of this shape. Once you do that, join all the points and you get your image. Now some of you will manage to do that after 1 point. Some of you will be required to do 8 points. There's no rush. Make sure you draw as many points as required for you to get the right shape. In part B, I need to describe this transformation. Obviously, the size of the shape changes, so we have an enlargement. If you look at the height of each triangle, the height of A is 1, the height of B is 3 units, so the scale factor is equal to 3. And we need to find the center of enlargement. Now for this, I'm gonna draw some lines that join corresponding vertices. I'm gonna join the upper point of B to the upper point of A, and I'm gonna extend this line, and then I'm gonna repeat with the left point of each triangle and extend, and you're gonna get the following. Now those two lines meet at the point 7, 2, and that's your center of enlargement. So let's write it here. Center of enlargement is 7, 2, and that's it for question 3. For part of question 4, start by cross multiplying. So 2x plus 5 is equal to 6, 2x minus 5. Let's expand the right hand side. This gives me 12x minus 30. Take all the numbers to the left, so I get 35. All the x's to the right, I get 10x, and then x is 35 over 10. This simplifies to 7 over 2. For part B, according to the rules of indices, I need to subtract the powers, so I get h to the power of 12. Part C, the power of 4 applies to all numbers and letters separately, so I get 2 to the power of 4, then g to the 3 to the power of 4, and k to the 5 to the power of 4. 2 to the 4 is 16, and then for the other two I apply the laws of indices, but I multiply the powers, so I get g to the power of 12, k to the power of 20. For part D, I'll multiply both sides by y to the 7, so this goes to the other side by multiplication, and divide by y to the 5, so this will come to the right with division, so I'll get y to the n is equal to y to the power of 12 times y to the 7 over y to the 5. Now on the right hand side, I've got multiplication and division. For the multiplication, I add the powers, and then for the division, I subtract. So if I continue here, y to the n gives me y to the power of 14. Therefore, n is just 14. For question 5, I'll start with the ratio butter to sugar, which is giving us 3 to 2. Now I have 120 grams of sugar, x grams of butter. Let's find x by cross multiplying. 3 times 120 over 2. X comes out to be 180 grams. This is the weight of butter. Now let's use the ratio F to B, flour to butter. This is 6 to 5. I know there are 180 grams of butter, y grams of flour. So y is equal to 6 times 180 over 5. Put this on the calculator, you're going to get 216. And this is the weight of flour and the final answer for this question. For question 6, I'll start with the left-hand side and convert the fractions to improper fractions. So I've got 24 over 7 divided by 8 over 3. Because of the division, I'll flip the second fraction to 3 over 8 and change division to multiplication. Now I will simplify the 24 with the 8, and then I'll multiply out. 3 times 3 is 9 over 7. Rewriting this as a mixed fraction is 1 and 2 over 7, which is equal to the right hand side. For question 7, I'll use the following formula. Final amount equals to the initial one times the multiplying factor. And in this question, I have a depreciation by 8% per year, which means that the multiplying factor is 92 over 100 per year. Now the 92 is 100 minus 8. So MF equals 92 over 100. Now because I have 3 years, I have to raise this to the power of 3 as a decimal at 0.92 to the power of 3 for all 3 years. So let's go back to the formula. Final amount equals to the initial 26,800 times 0.92 to the power of 3. Plug this into the calculator and you'll get an answer of 20,869. In this type of questions, I always like to summarize what I'm given on a table. And I'm going to use the formula mean equals sigma x over n. Sigma x is the sum, n is the number of games played. I know that initially there are 8 games with a mean of 6. 2 more games are being played, each with a score of k goals. So the sum for those 2 games is k plus k, which is equal to 2k. And then I have a total of 10 games with a mean of 7. Now the total number of goals scored for the first 8 games is 8 times 6, which is 48. And now I'm going to create an equation based on this rectangle. I can find the value of this rectangle either by adding those 2 values or by multiplying those 2 numbers. So the equation I get is the following: 48 plus 2k, which is the sum of those 10 numbers, must be equal to the mean times 10, which is 70. So let me rewrite at the bottom the equation. 48 plus 2k is equal to 70. Let's solve this now. 2k is equal to 22. So k comes out to be 11. For question 9, I'll start with the formula for the gradient. So m equals, let's substitute the numbers in, 0 minus minus 3 over 2 minus 0. Gradient comes out to be 3 over 2. Note that one of the points has an x-coordinate of 0. Therefore, the y-intercept is equal to minus 3. So now I can just write down the equation of the straight line. General form, y equals mx plus c. In this case, y equals 3 over 2x minus 3. In question 10, I'll need to divide this shape into smaller, more familiar shapes. One way of doing this is the following, where we get 2 rectangles and 1 trapezium. The formula for the area of the trapezium is the following. Now the 2 bases for the trapezium are x plus 2 and x plus 6. The height of the trapezium is this height here, which is equal to 25 minus 7 minus 8, which is equal to 10 centimeters. So now I can write down an equation where the sum of the 3 areas is equal to 258. So 8x plus 2 plus the area of the trapezium, base 1 plus base 2 times height over 2 plus the area of the purple rectangle, 7x plus 6. And this, as I said before, is equal to 258. For the trapezium, I can simplify the 10 and the 2, and this bracket here is equal to 2x plus 8. So now I can expand and get 8x plus 16 plus 10x plus 40 plus 7x plus 42 equals 258. Let's simplify the left-hand side. 25x plus 98 equals 258. Now solving this one will give me x is equal to 6.4, and that's my final answer. For part A of question 11, I need to complete the missing probabilities. Now, obviously, these two need to add up to 1. So the bottom one is 11 over 16. Now, for the other one, I'm picking from box Y. There are 7 red. So 7 over 20 is the red, same as the branch below. And as I said before, I need the complementary probability. That's 13 out of 20. So they add up to 1. In part B, I need the probability that seed takes 2 of the same color. So I want either 2 red or 2 which are not reds. So now I'm going to multiply and then add each combination. So for the red combination, I have 5 over 16 times 7 over 20. And then I need to add the blue combination, which is 11 over 16 times 13 over 20. Put that on the calculator and you get an answer of 89 over 160. For part A of question 12, I'll convert the 4s as powers of 2. So I get 2 to the 7 times 2 squared to the power of 5 is equal to 2 squared to the power of x. Now I'm going to use the rule of indices where I have to multiply those powers. So 2 to the 7 times 2 to the 10 equals 2 to the 2x. I'll continue on the side. Now I'm going to add the 2 powers on the left. So 2 to the power of 17 is equal to 2 to the 2x. Therefore, the 2 powers must be the same. 17 is equal to x, which means that x is 17 over 2. For part B, the power 2 over 3 applies to every number or letter. So 125 to the power of 2 over 3 times p to the power of 6 to the power of 2 over 3 times y to the 24 to the power of 2 over 3. Now for the first one, this one, just put it on the calculator. Answer comes out to be 25. For the other one, you need to multiply the powers. So you get p to the power of 4 times y to the power of 16. For question 13, you can find the interquartile range using inspection. The median is the middle value. Since these are in order, the middle value is 8. And then for the left part, the 5 numbers from 1 to 6, their middle number is 4. That's Q1. And then for the 5 numbers to the right of the median, their middle number is 13. So the interquartile range is Q3 minus Q1. So 13 minus 4 will give me a 9. Now, if you want a more algebraic or calculation method, then Q3 is equal to 3/4 of n, which is 11. I have 11 observations. This is 8.25, which means I'm going to take the 9th observation, and the 9th observation is 13. Q1, find a quarter of n, a quarter of 11. This is equal to 2.75. Always round up. Take the 3rd observation, which is 4, and then again 13 minus 4 gives you 9. For question 14, I already have one equation drawn, so I'll need to draw the second one here. To do so, first I will rearrange and get y on its own. And now I'm going to make a table of x and y values. I'm going to put 3 random x values, minus 2, 0, and 2, and use the formula above to calculate their y values. This come out to be 0 to 4. So now I can plot those 3 points. And then I'm going to join them using a ruler. and that's the equation y equals x plus 2. Note that these two lines intersect at the point minus 1, 1. Therefore, the solution to the simultaneous equations is x equals minus 1, y is equal to 1. For part A of question 15, I'll start by writing x equals 0.3727272 and so on. So what is being repeated is the 72, and the first 72 I get in this number is the following. And note that this 72 begins one place after the decimal, ends 3 places after the decimal point. Therefore, I'm gonna need the 1000x and the 10x, so I can subtract them. 1000x is 372.72 and so on. 10x is 3.72, and if I subtract, I get 990x is equal to 369, and all the decimals disappear. So x is 369 over 990, which simplifies to 41 over 110 as required. For part B, I need to write that expression in a single square root. I will start by rewriting those two in simpler forms. So the square root of 125 can be split into square root of 25 times square root of 5, which is 5 root 5, and the red one, which is square root of 80, can be written as square root of 16 times square root of 5, which is 4 square root of 5. So now the original expression, square root of 125 plus square root of 80 over square root of 3, can be written as 5 root 5 plus 4 root 5 over the square root of 3, and this gives me 9 root 5 over root 3. And now I have to put everything together as a single root. So I'm gonna write the 9 as square root of 81. I'll keep the other two the same. And now I'm gonna put everything under a single square root. So 81 times 5 over 3. Do this calculation and you get 135, and don't forget the square root. For question 16, I'll start by keeping the first bracket the same and expanding the second bracket, so I get x squared minus 5x plus 4x minus 20. Now let's simplify that second bracket, x squared minus x minus 20. And now let's expand everything. 2x to the power of 3 minus 2x squared minus 40x plus 3x squared minus 3x minus 60. And if I collect like terms, I get 2x to the power of 3 plus x squared minus 43x minus 60. For question 17, I'll start by finding the lower and upper bounds for a, c, and y. For a, the lower bound is 8.25, upper bound 8.35. For c, lower bound is 1.5, upper bound 2.5. And for y, since it's being rounded to the nearest 5, I need to subtract and add half of that, so 2.5 to the 15. So lower bound is 12.5, upper bound is 17.5. Now I need the upper bound for p, and since I have a product, the upper bound of a product is the upper bound of the first term times the upper bound of the second, and the second term is a sum. The upper bound of a sum is the sum of the two upper bounds. So now I can replace those numbers. 8.35 times 2.5 plus 17.5. If you do this calculation, you get exactly 167. For question 18, I'll start by differentiating the displacement to get the velocity. So v is equal to ds dt. Now to differentiate, you multiply each coefficient by the current power, and then you reduce the power by 1. So for the first term, I'm going to do 2 times 3, 6t, and then reduce the power by 1. For the second one, minus 5 times 2 is 10, t to the power of 1, no need to write it. For the next term, 6t, the power of t is 1, so 6 times 1 is 6. T to the power of 0, no need to write it. And the last term is a constant, the derivative is 0. To find the acceleration, I need the derivative of the velocity. Same procedure, 6 times 2 is 12, t to the 1 minus 10. This is an expression for the acceleration. Question says acceleration is 5, so I'm going to set this equal to 5. So 12t is 15. T comes out to be 1.25, and that is the required answer. For part A of question 19, the problematic value is any value of x that makes the denominator of g being equal to 0. So I'm going to take the denominator, set it equal to 0, and solve to find that x is 9 over 2. So this cannot be included in the domain. For part B, I'll start by finding g of 4. So 5 over 2 times 4 minus 9. Answer comes out to be minus 5. And then I'm going to do f of minus 5. So 5 times minus 5 plus 7 comes out to be minus 18. And that's the required value. For part C, I need to find the inverse of h. Now h is a quadratic. Whenever you have a quadratic and you need to find the inverse, always complete the square. So I'll start by writing h of x equals, I'm going to take a 3 as a common factor from the first two terms. So I get x squared minus 4x, close the square bracket, plus 8. Now I'm going to focus on what is inside the square bracket. So let's complete the square of that expression. That's the formula for completing the square. So if I use that with the given numbers, I get x minus 2 squared minus 2 squared. When you simplify that, you get x minus 2 squared minus 4. So let's go back to the function h. So I have 3 square brackets, x minus 2 squared minus 4, close the square bracket, plus 8. Let's expand the square brackets only. 3x minus 2 squared minus 12 plus 8. If I simplify, I get 3x minus 2 squared minus 4. So consider this to be y equals to that expression. And in order to find the inverse function, I need to replace the x's with the y's. So I will get x equals 3y minus 2 squared minus 4. And I need to rearrange to get y on its own. So x plus 4 is equal to 3y minus 2 squared. Divide by 3. X plus 4 over 3 is equal to y minus 2 squared. Now I'm going to take the square root of each side, plus or minus the square root of x plus 4 over 3 is equal to y minus 2. And finally, I'll come to the right. Y is equal to 2 plus or minus the square root of x plus 4 over 3. Now for the original function, x was greater than 2. So for the inverse function, y must be greater than 2. So out of the plus or the minus, I'm going to keep the plus, so I make sure that y is always 2 plus something, so y is greater than 2. So the inverse function is 2 plus the square root of x plus 4 over 3. In question 20, I have an equilateral triangle, which means that all angles are 60 degrees. Now I need to find the radius of the circle inside that triangle, and in order to do so, I will join A to E, B to F, and C to D. So now I have divided triangle ABC into 6 smaller right angle triangles. I know they are right angle triangles because angles AB, BC, and CA are tangents to the circle, and the angle between tangent and radius is 90 degrees. So let's pick one randomly. Let's choose this triangle here, and let's extract that triangle to the bottom. Note that this angle is 30 degrees because by symmetry, this line here divides this angle into 2 equal parts. So let's find the radius using trigonometry. Tan of 30 equals radius over 5. So radius is 5 times tan 30. So radius is equal to 5 square root of 3 over 3. Now that I know the radius, I can find the area of triangle ABC and then subtract the area of the circle to find the shaded area. The area of triangle ABC can be found using the following formula. So I get 1 over 2 times 10 times 10 times sine of 60. This gives me 25 square root of 3. And the area of the circle is given by pi r squared. So pi times 5 root 3 over 3 squared is equal to 25 pi over 3. Therefore, the shaded area is given by 25 square root of 3 minus 25 pi over 3, and this gives an answer of 17.1 centimeters squared. I'll start question 21 by rearranging the linear equation to make x the subject. So x equals 5 minus 2y, and then I'm going to replace the x into the nonlinear equation with 5 minus 2y. So I will get 5 minus 2y squared plus 3y squared is equal to 13. Let's expand. 25 minus 20y plus 4y squared plus 3y squared is equal to 13. I'm going to take everything to the left and collect like terms. So 7y squared minus 20y plus 12 is equal to 0. That's a quadratic equation. You can use factorization, completing the square, or use the quadratic formula. I'll go on with factorization. So 7y minus 6 times y minus 2 is equal to 0. This gives me 2y values. Y is equal to 6 over 7, or y is equal to 2. Now I'm going to substitute each of those values into this equation to get the corresponding x coordinates. So x is equal to 5 minus 2 times 6 over 7. X is equal to 23 over 7, or x equals 5 minus 2 times 2. X is equal to 1. So the points of intersection are 23 over 7, 6 over 7, or 1, 2. For part A, I need to find OC, and note that OC is equivalent to OB plus BC. Let's write this down. OC equals to OB plus BC. Now OB is 4B, BC is 2A minus 2B. Simplify and you'll get 2A plus 2B. Then I need to find A and B. Now A and B is this one. That's equivalent to AO plus OB. So A and B is equal to AO plus OB. Now AO is the reverse of OA, so it's minus 3A plus 4B. Doesn't simplify, so that's the answer for A and B. For part B, I need to find the ratio AP to PB. Let's go to the diagram. Note that I have a point P such that it divides the lines A and B and OC. Now, I don't know the fraction of AP to A and B. I'm going to call it lambda or any other letter you want. Therefore, PB is the remaining, that's 1 minus lambda. Similarly, I don't know the fraction of OP relative to OC. I'm going to call this mu a different letter, any letter you want, and 1 minus mu is PC. So now I'll find two versions of the same vector, any vector. I'll take AP because it's convenient and equate coefficients. So AP is equal to a fraction lambda of AB, as you can see from the diagram, which is lambda of minus 3A plus 4B, which I found before. If I expand this, minus 3 lambda A plus 4 lambda B. Alternatively, I can find a different route for AP. I can go from A to O and then from O to P. Now AO is minus 3A and OP is fraction mu of OC. Now OC I found above, that's 2A plus 2B. Let's expand. Minus 3A plus 2 mu A plus 2 mu B. I'm going to factorize the A in the first two expressions. Here it is. So if I take A as a common factor, I'll have minus 3 plus 2 mu, and then I have 2 mu B. So in the first expression, I've got minus 3 lambda A's, and in the second expression, this one, I have so many A's. Similarly, the first expression, 4 lambda B's, in the second expression, 2 mu B's. So the two blue numbers must be the same and the two red numbers must be the same. Let's write down those equations. Minus 3 lambda equals minus 3 plus 2 mu, and 4 lambda equals 2 mu. If I simplify that, I'll get 2 lambda equals 2 mu. So now I have to solve them simultaneously. I can replace this mu here with 2 lambda. Therefore, minus 3 lambda equals minus 3 plus 2 times 2 lambda. Minus 3 lambda equals minus 3 plus 4 lambda. 3 equals to 7 lambda, and lambda is equal to 3 over 7. Now recall, I need to find the ratio AP to PB. As you can see from the diagram, this is equal to lambda to 1 minus lambda. I found lambda to be 3 over 7. Therefore, 1 minus lambda is 4 over 7. And if I simplify this, I'll get 3 to 4. And that's the final answer. For question 23, the volume of the given shape is equal to the volume of the large cone minus the volume of the small cone. Let's write this down. Volume of frustum equals volume of the large cone minus volume from the small one. The volume of a cone is given by the following formula. So let's substitute what we have in this equation. 4,212 over 25 pi is equal to 1 over 3 pi 6 squared times 15 minus 1 over 3 times pi x squared times the height of the small cone. Now I need to find the height of the small cone in terms of x. So let's go back to the shape. Consider the following triangle, and h is the height of the small cone. Using the properties of similar triangles, h over x is equal to 15 over 6. Therefore, h is equal to 15 over 6x. You can simplify this to 5 over 2x. So now I can write the height as 5 over 2x. Let's simplify. 4,212 over 25 pi is equal to 180 pi minus 5 over 6 pi x to the power of 3. I can divide everything by pi. So 4,212 over 25 is equal to 180 minus 5 over 6 x to the power of 3. Let's rearrange to get 5 over 6 x cubed on its own. So 5 over 6 x cubed is equal to 180 minus 4,212 over 25. Put that on the calculator and you'll get 288 over 25. So x cubed is 288 over 25 divided by 5 over 6, which gives me 1,728 over 125. So take the cube root of that. X comes out to be 12 over 5 or 2.4 as a decimal, and that's the final answer. For question 24, I'll work with each of those terms separately, simplify them, and then solve the equation. So let's split them up. So for the blue expression, I'll take out a common factor of 5x, and I'll be left with 9x squared minus 16. And then for the denominator, I will factorize, and I'll get 3x plus 4 times x minus 1. Now, this bracket here, that is the difference of two squares. So I get 5x, 3x plus 4, 3x minus 4. And then the denominator will stay the same. 3x plus 4 times x minus 1. The 3x plus 4 cancels out. So I'm left with 5x times 3x minus 4 over x minus 1. I'm going to leave this as it is. Next, I'll proceed with the red expression. I'll write those two fractions as a single one. The common denominator is x times 3x minus 4, and the numerator is x plus 3x minus 4. Let's simplify the numerator. That's 4x minus 4. Denominator stays the same. I will not expand. And finally, I will factorize the numerator for x minus 1 over x 3x minus 4. So now blue expression times the red expression is equal to the left-hand side of the equation. There's a lot of simplifying on the left-hand side. I can simplify the x with the x. I can simplify the 3x minus 4 with the 3x minus 4. And I can simplify the x minus 1 with the x minus 1. So the left-hand side simplifies to 20. And then I'll expand the numerator of the right-hand side. So 4x plus 8 over 5x minus 8. Now I'll cross multiply. 20 times 5x minus 8 is equal to 4x plus 8. I'll expand the left-hand side. 100x minus 160 is equal to 4x plus 8. I'll take all the x's to the left, so 96x is equal to 168. So x is 168 over 96. Simplify this and you'll get 7 over 4, which is the final answer.